topic of today is assessment of moderator. But before going to assessment of moderator, we need to know about the concept of moderator. When we say moderator, what we mean? Actually, moderator is, last week, I think, very briefly, I explained. Moderator is a variable that based on different levels of this variable, we believe when we apply a moderator, we believe some relationship should be changed based on levels of moderator. For example, when we say x, we have x to y, we have effect of x, we have effect of x to y, right? So there is a path coefficient, beta coefficient here between x and y. So for the effect of x to y, for example, this beta coefficient or path coefficient is 0.4, right? So this relationship is for whole data set or all sample, right? For example, if we have 400 sample, and based on this 400 sample, we calculate beta coefficient for effect of x to y. So we have regression line and regression equation for this relationship, right? So we have some data point, and based on this data point, we we estimate this line as a regression line for effect of x to y, and the beta coefficient is a slope of this line. So when beta coefficient is 0.4, means the slope of this line is 0.4 for this relationship, okay? So this can be calculated, this can be estimated based on regression equation, and this beta represent effect of x to y. But when we introduce moderator, for example, for the effect of x to y, we introduce gender as a moderator. So we have gender here, right? We have gender, and gender has two levels, male, two value, male and female. Okay, male and female. So when we introduce moderator for this relationship, this is schematical representation of moderator. We connect arrow from moderator to relationship, right? So when we introduce gender as a moderator for this relationship, we believe effect of x to y should be different, significantly different for male and female. For example, if out of 400 sample, 250 are male and 150 are female. So when we introduce this moderator, we mean effect of x to y for these 250 sample. For example, the effect of x to y for male is something similar to this line. So the path coefficient, the beta coefficient for the effect of x to y for male for this 250 sample is 0.8 or 0.7, right? So the effect for the effect of x and y is beta coefficient is 0.7. And the effect of X to Y for female for this 150 sample is, for example, 0.1. 0.1. So when we combine these two, relationships, when we combine our sample and create 400 sample, so this effect of 0.1 and 0.7 will be combined and will create this 0.4, right? So this 0.4 is a combination of effect of male and female. But when we separate this sample, our data, to two groups, male and female, and estimate this effect, this relationship separately for male and female, we can see different beta coefficient for each one. Sometimes the difference between these two beta coefficient is significant. So these two are significantly different. For example, like here, 0.7 and 0.1. So the effect of X to Y for male is significantly stronger than effect of X to Y for female, right? Because the effect of X to Y for male is 0.7, but for female is 0.1. So moderator, gender as a moderator is significant moderator for this situation. But if effect of X to Y for male and female almost is similar, okay, let me delete this too. Okay, so effect of X to Y for male is very close to 0.4. For example, is 0.37. And for female, and for male is again very close to 0.4, parallel to 0.4, or a bit different, is for example 0.42. So here you can see the effect of X to Y for male is 0.42 and for female is 0.37. So the difference between these two effects is not significantly different. So if we have this situation, it means there is no difference between two groups that we have, between male and female, two levels of moderator. So in this case, moderator would not be significant. So this is the concept of moderator. When we say gender moderate relationship between X and Y, it means effect of X to Y should be significantly different for two levels of moderator, for male and female. For size of company, for big company and small company, right? For two age group, for young people and old people. So this is the meaning of moderator. So what's the moderator hypothesis? What's the moderation hypothesis? Moderation hypothesis exactly represent this concept. When we have gender as a moderator, so we can say gender moderates relationship or effect of X to Y. This is one way. Another way that is better way, and literature suggests this way of hypothesizing moderator, we can say, based on literature and based on theory, effect of X to Y, relationship between X and Y, is stronger for male compared to female, right? Effect of X on Y is stronger for large company compared to small company, right? So this is another way of a moderator hypothesis, another way to write moderation hypothesis. So this is the concept of moderator and the way that we hypothesize moderator. Let me show you two examples. Okay, this is two of our papers. This paper published 2020, recent one. In this paper, actually, this is our framework. This is our framework in this paper. So we have effect of functional value, emotional value, and social value on satisfaction and revisiting tension, right? And social value also is addition to antecedent or independent variable, is a moderator for the effect of emotional value on satisfaction. So social value plays two roles. Independent variable that directly affect on satisfaction, and also moderating variable for effect of emotional value on satisfaction. So here we can see moderating hypothesis. Okay, this is a moderating hypothesis. In this paper, actually, we use this way of moderating hypothesis. Before we explain why this social value moderate relationship between emotional value and satisfaction, and this is the hypothesis. Perceive social value positively. Later, I will explain what this positive and negative moderator means. Okay. Perceived social value positively moderates the effect of perceived emotional value and satisfaction, or the relationship between perceived emotional value, effect of perceived emotional value on satisfaction. So this is one way for writing moderation hypothesis, right? That we use this way in this paper for this hypothesis. This is a schematical way for presenting moderator hypothesis. We use dot line for a moderator, and this line, this arrow come from, this dash arrow come from moderator to effect or relationship between X and Y, right? So this is one way. Another way, okay, we have another paper here. In this paper, actually, we hypothesize location. Location as a moderator for relationship between IV and DV. Okay, so in this paper, we try to assess, we try to compare effect of antecedent on perception between people those are living in the vicinity of heritage site, tourism site, and the people that are living far from tourism site, far from heritage site, right? So we compare effect of IV to DV between these two groups, So here you can see hypothesis for this relationship. Okay, community attachment. The effect of community attachment on resident perception. So effect of X on Y is stronger for resident living within the vicinity of heritage tourism site. Okay, so here we use another way of moderation hypothesis. Here we say effect is stronger for one group and weaker for another group. So H2 refer to this hypothesis. This is H2. And H2 is for the effect of community attachment on perception. And we believe and discuss that effect of community attachment on perception is stronger for the people that were living in vicinity of heritage site or within heritage site, right? So this is another way of hypothesis development for moderator. But actually here also we have another hypothesis. Community attachment is stronger among residents living within the vicinity of heritage site. So, but first hypothesis doesn't refer to any relationship, doesn't refer to any effect, right? Only we want to see community attachment for two groups of people. People are living in heritage site and people are living out of heritage site, far from heritage site. So we don't have any effect, any relationship. This one is not moderator hypothesis. This one is not moderator. Moderator only refer to difference between effect of X on Y. But in first hypothesis, we don't have any effect. What we need to do for first hypothesis? Any answer?
The first hypothesis, the community attachment is actually a dependent variable, right?
So what test we have to use for this hypothesis? T-test. Yeah.
T-test direct.
Yeah. So the first one is a simple t-test, independent t-test, right? Independent sample t-test. But second one refer to relationship. So it's moderator, right? So we say effect of community attachment on perception is stronger for one group compared to other. Always moderator can be very good contribution, okay? We published this paper 2019 in Journal of Sustainable Tourism. Journal of Sustainable Tourism is one of the best in tourism, right? But there are many papers that actually investigate this relationship. Many papers that investigated this relationship, effect of some antecedent on perception. But why still we could manage to publish in this top tier and good journal? Because of this because of theoretical contribution of this moderator. Most of time, moderator, if you find a good moderator can be a significant theoretical contribution, right? So if sometimes you ask, okay, if there is an established theory, an established model, how this model can create theoretical contribution and justify for an original work. Most of time, finding a good moderator can help you to use an established model, but still provide theoretical contribution and convince editor reviewers to publish your work. Good journal, right? So the concept of moderator and understanding moderator is very, very important and critical and helpful, right? Okay, so this is two ways for moderator hypothesis. Any question? Methods for assessment of moderator. Creating interaction effect and analyzing interaction effect, significance of interaction effect. This is one way for assessment of moderator. And another way for assessment of moderator is multi-group analysis. So it's dividing our data set to two groups and analyze our framework, our model based on these two groups and compare the result of these two groups. Compare the result of beta coefficient for these two groups. So this is two ways for assessment of moderator. First one, it's not certain, it's not for all situations, but most of time, when we have a categorical variable, with two groups or categorical variable more than two groups, when we have a categorical variable for two groups or more than two groups, it's better to apply multi-group analysis, second approach. But when we have a continuous variable, for example, a latent variable with some items, right? And we want to see effect of this moderating effect of this latent variable, like social value. In first paper that I show you, social value is a latent variable including a few items measured based on some items. So when we have this type of moderator, or most of time for a categorical variable for two groups, it's better to apply interaction effect. But even for continuous variable, it's possible to apply multi-group analysis in some situation. And for a categorical variable with two groups like gender, it's possible to apply multi-group analysis, and also it's possible to apply interaction effect, right? So this is actually a situation that we can use interaction effect or multi-group, but most of time for continuous, we apply interaction effect, and multi-group is for categorical variable, right? Another way to differentiate between two methods is when moderator only moderates one or two relationship in a framework. For example, we have 5 antecedents that influence on IV and influence on DV, or mediator and mediator influence on DV, right? So we have this framework, but moderator only should be assessed for one relationship. For example, moderator, mediator to DV, or one IV to mediator. If moderator should be assessed only for a few relationship, a few effects in our framework, it's better to apply interaction effect. But if moderator moderate relationship between all variables, moderates all effects in our framework, it's better to apply multi-group analysis, even for continuous variable, right? So this is another way or criterion to distinguish between these two methods of assessment of a moderator. Which one we use, which one we apply for moderator assessment, right? Later, when we go through these two methods, this will be more, this will be clearer. Okay, so we have these two methods. Okay, first one, interaction effect. Based on first method, actually we need to create interaction effect between IV and moderator. IV and moderator. So when we apply this method, this is the way that we show a moderating hypothesis or moderating variable, right? So with the dash arrow to relationship between X and Y. Okay, when we apply this interaction effect, actually, this is a statistical relationship for application of interaction effect. So when we apply interaction effect, actually we add, this is X to Y. So we add two more relationship in our framework. So we add this effect of moderator to dependent variable, this one, and also include effect of this term xm, and this xm is interaction term. This xm is independent variable multiply moderator. So we create a new variable xm by interacting IV and moderator, by multiplying IV and moderator. So we create this new term. So when we apply interaction effect, these two terms are added to regression equation. Before including moderator, regression equation is Y, right? Y B0 or beta 0, beta 1, X, right? So when we don't have this moderator, only we have X to Y. So this is regression equation for X to Y, right? But when we add moderator using interaction effect, we include these two terms, M, moderator, and XM, interaction between X, independent variable, and M. So these two terms are added to this regression equation. So here we add B2M plus B3 XM. This term called interaction effect. This term called interaction effect. And we assess significance of this interaction effect, means significance of this B3 for assessment of moderator, for assessment of significance of difference between effect of X to Y for level 1 and level 2 of moderator. Okay. So using interaction effect, we add these two terms to regression equation. And we assess this B3. But why we do this one? Why we do this? Why interaction effect actually can show us the difference between level of the difference between effect of X to Y for two levels. Why? Okay. Why is here? Listen carefully. I actually want to explain the rationale behind interaction effect for assessment of moderator. And this may be a bit complicated, but actually it's, if you listen carefully, it's very simple, right? Okay. This one can be changed to this equation, right? Okay. Original one is y b0 plus b1x plus b2m plus b3xm plus arrow, right? This one. So this one we have here. Okay. Now we have this equation. When we include moderator and interaction effect in regression equation. So this one, this equation easily can change to, can convert to this equation, right? Okay, if we put, so y is beta b0 or beta 0 plus, not include x, b2m plus error. We put all this in one bracket, one parenthesis, plus, so now we included this one, and this one. So we have another two terms, b1, this term, plus this term, b3m x, right? So this equation now is exactly same as this equation, right? So we can transfer, we can convert this original equation after including interaction effect and moderator to this equation, right? Okay. So now we have this equation, right? Okay. M is moderator. Let's say moderator has two levels because we want to compare. We want to compare effect of X to Y for level 1 and level 2 and see there is significant changes, there is significant difference between effect of X to Y for level 1 and level 2, right? Okay, so let's say M is gender. M is gender, right? And male and female. Male and female. So we give 0 and 1 because we have 2 levels. Can give 0 and 1, 1 and 2 to M. So M include 2 values, low and high, male and female, right? So M is 0, low level, and 1, high level of M. Because for moderator, we have only 2 levels. We want to compare these 2 levels. We want to see when moderator change, what happened to relationship between X and Y. Okay. So in a simple way, we can consider M 2 levels, 0 and 1. For 0, what happened to this equation? For 0, okay, when M is 0, this one will be 0, this one will be 0. So Y will be B0 plus error plus B1 X, right? For M0, the relationship between X and Y is B0 plus error plus B1X. So the slope or beta coefficient for the effect of X to Y will be B1. Let's draw the equation line. So this is equation line for this one, for low level of moderator. So this slope is B1, right? This is pad coefficient, beta coefficient. Okay. What happened to this equation when M changed to 1? What happened? So for M1, Y will be, so this one is for M0. Now for M1, Y is B0 plus B2 plus error plus, okay, here will be B1 plus B3X, right? So this one is intercept, is constant level, constant value, right? So here, this intercept is B0 plus error. But for this one, will be, for example, here. So it's B0 plus B2 plus error. Okay. But what's the slope of this line? What's the beta coefficient for this line? Beta coefficient for this line is B1 plus B3. right? Because this is a regression equation for high level of moderator, and this is for low level of moderator. So for one, the relationship is the pad coefficient, beta coefficient is B1 plus B3. But the first one, the relationship, the slope, beta coefficient is B1. So what's the difference between effect of X on Y for high level of moderator and low level? For high level of moderator, beta coefficient is B1 plus B3, right? For this one. For low level of moderator is B1. So the difference between these two beta coefficient is B3. What's this B3? B3. What is this B3? B3 is pad coefficient or beta coefficient of interaction effect. So if interaction effect is significant, coefficient of interaction effect is significant, it means difference between effect of X on Y for low level and high level of moderator is significantly different. Refer to first example that I show you. Effect of X to Y is 0.4 for all data set. But for male, when we separate male and female, effect for male is 0.7. Effect for female is 0.1. So the difference between effect for male and female is 0.6. So this 0.6 is effect of interaction term. So if this is significant, means there is significant difference between effect of X to Y for high level of moderator. For high level of moderator compared to low level. If effect of X to Y is higher for high level of moderator, we say effect of X to Y is stronger for high level of moderator. Right? And when the effect of X to Y for high level of moderator is stronger, means moderator or interaction effect is positive. Positive. Okay? Different methods to create interaction effect. Here we have 4 methods. One is a product indicator approach. Another one is two-stage approach. Another one is a hybrid approach and orthogonalizing approach, right? So I don't go through this different method, make it confusing and difficult. Only very briefly, I refer to 2 first methods, but you don't need actually to do this one manually or understand exactly what's the concept. You can choose one of this method and do by software. So the most important things, you have to create and add interaction effect in your framework, in your model, right? But first is product indicator. For example, if moderator is this variable with the 2 item, this is, and you have a independent variable or exogenous variable with 2 items. Interaction effect will be a new variable with 4 items, right? x1 multiply m1, x1 multiply m2, x2 multiply m1, and x2 multiply m2. Here you can see. So interaction effect xm, this is interaction effect xm, because we want to assess this coefficient. This xm includes 4 items. For example, if your IV, exogenous variable, has 5 items and your moderator has 5 items, so interaction effect will have 25 items. So you create a new variable with 25 items. So this is product indicator approach to create interaction effect. Another method is two-stage. In two-stage approach, we calculate score of latent variable. So after calculating a score, we have only one item, one indicator for IV and one indicator for DV. Okay, here we can see score of IV and score of DV. So interaction term is 1 multiply 1. So it's one indicator, one item. So it's another approach. If one of your IV or moderator, either your IV or moderator, one of them is formative and another one is reflective, this method is not possible to apply. Only you have to apply two-stage. If one is moderate, one is formative, and one is reflective. In software, you have different choices. You have different choices for creating interaction effect. So this one is for creating interaction effect. But the most important things for assessment of moderator is to assess significance of this interaction effect. Okay. So this one is for creating interaction effect. Hybrid approach is not possible to create based on available software. Some software has an option for orthogonalizing approach, but actually orthogonalizing approach is not common. But if we have few indicators, so the number of indicators is very low, or your sample size is small sample, maybe orthogonalizing approach is a better approach for creating interaction effect. But orthogonalizing approach is different with this two-stage and the product indicator. But the final product of all these approach is interaction effect. And what we need is to create this interaction effect because we want to assess this beta 3, significance of beta 3. Okay. if you have a formative, you have to use two-stage. Yeah, this one is a bit confusing for your level. Just skip it. Okay, so these two actually can be two regression line for effect of IV to DV for example, high level of gender and low level of gender. Okay, here you can see high level of gender and low level of gender. So for high level of gender is this line. You can see the slope is higher for high level of gender, and here is lower compared to this one. So it means for high level of gender, if high level of gender is female, for example, female is 2 and male is 1. So high level of gender is female. So it means the effect of X to Y is stronger for female compared to male. Okay. For interaction effect, we can calculate effect size based on this formula, but actually calculating of the effect size for moderator is not very significant. Even for very low effect size, when we have a significant interaction effect, it means the relationship or the effect of X to Y is significantly different for high and low level of moderator. Even effect size and changing of R square is very low. So it doesn't matter what's the value of effect size, and we don't consider this one. Only we need to assess significance of interaction effect. If interaction effect is significant, means there is significant difference between high and low level of moderator for effect of XIV to D. Okay, so only we look at beta coefficient of, only we look at path coefficient of interaction. If this path coefficient, if this beta coefficient is positive and significant, if it's positive and significant, means if it's positive and significant, means effect of X to Y for high level of moderator is stronger. So all is about X to Y, right? So when we have moderator M, if this path coefficient is positive, interaction effect and significant, if it's positive and significant, means effect of X to Y is stronger for high level of moderator. For high level of moderator. But if this interaction effect coefficient, this interaction term coefficient is negative, but significant, it's negative and significant, it means the effect of, X to Y for high level of moderator, is weaker weaker than the effect of X to Y for low level of moderator. So here, for low level of moderator, the effect is stronger, right? So what's the meaning of sign? For positive coefficient of interaction effect. And significant means effect of X to Y is stronger, is higher, the slope is higher for high level of moderator. For example, for high involvement, for big company. But if interaction effect is negative, it means effect of X to Y is weaker for high level of moderator, for big company, for high level of involvement. The effect of X to Y is weaker, is lower. The slope is lower compared to low level of moderator. So when we say moderator is positively or M positively moderate effect of X to Y, means effect of X to Y for high level of moderator should be stronger. When we say negatively moderate, means effect of X to Y for high level of moderator should be weaker, and for low level of moderator should be strong, right? So let's go to software and see how we can create first interaction effect in software, and how we can assess the moderator using the interaction effect in software and report. Okay, let me share software. Okay. So now you can see my screen, right? Software screen. This is a SmartPLS model that we actually created for last session, and now we want to add the moderator to this framework and see how we can create and assess moderator using interaction. When we want to apply interaction involvement, my hypothesis for moderator is effect of economic perception on support is stronger for people, for residents with high level of involvement. So this is the hypothesis for moderator, right? Oh, let me write this. Okay. H1 effect of resident perception on support is stronger for resident with the high level of involvement. Okay. So the hypothesis is effect of perception on support is stronger for residents with high level of involvement. Another way to write moderating hypothesis is involvement moderates positively. Involvement moderates positively effect of perception on support. So involvement is here, and involvement moderates this relationship, but positively. Again, positively means effect of perception on support is stronger for high level of moderator, for people with high level of involvement. Right? Okay. So this is moderation hypothesis. We want to test this moderation hypothesis. To test this moderation hypothesis, we have to create interaction effect. But in software, before creating interaction effect, we have to create moderator variable. So here we need to create a new variable, and this new variable is involvement. So we assign these items to this new variable, change the name to involvement. Okay, and connect this involvement to DB. Connect involvement to DB to create regression equation that we need for assessment of moderator. Okay. So now we included involvement and connect involvement to DB. But we need to create it. Now we need to create interaction effect. To create interaction effect, here in this menu bar, you can see this option, moderating effect. Right? This option. Right? So we have this moderating effect option. If you click on moderating effect, now you are able to create interaction effect. You have to click on DV. When you click on moderating effect, okay, you have to click on DV. You can see DV is green. When you click on DV, you will come to this page. You can see this page, new tab.
Yes, yes.
Okay. So here you have some option to create interaction effect, to create moderating effect. There are two different boxes here. First one is moderator. You have to choose. You have to select your moderator. So when you click on this tab, you can see this variable. What's your moderator? Involvement. Okay, so click on involvement. And independent variable. Independent variable. Independent variable means the variable that you want to moderate involvement for IV and DV. Between this IV and DV. click on independent variable. What's your independent variable? Okay, here. You want to, yeah, you want to see effect here between perception and support. So the independent variable to create interaction effect is perception. So click on perception, economic perception, right? The name of variable is economic perception. So click on perception. So you select moderator and you select independent variable that you want to create interaction effect between this ID and moderator. Here you can choose different methods. Product indicator. If both are reflective, you can choose product indicator or two-stage. If one of the moderator or IV is reflective and one is formative, you have to choose two-stage. But if you choose two-stage, you are safe. Two-stage can be selected for all situations, right? And here you can see the default is two-stage. Product term generation, you have to keep the default standardized, and the weighting scheme, weighting mode, you can keep automatic. When you keep automatic, so mode A will be used for reflective and mode B will be used for formative. Also, we have some other methods, but you keep automatic default. So for these two settings, just keep the default. Okay. And now you can click on OK. So when you click on OK, you can see this new variable and effect. This variable is interaction term of economic perception and involvement. Actually, this moderating effect is economic perception, interact, multiply, involvement. So this is this interaction term. Economic perception, interact, involvement, right? So this is interaction term. For assessment of moderator, for assessment of moderation role of involvement, we have to check and we have to assess significance of this path, interaction term or interaction effect coefficient, right? So to check this one, we have to run bootstrapping. First, we can run PLS algorithm to see the result, to assess measurement model and original structural model if you want to assess, and for significance of this one. Okay, here you can see first is negative. Before we run bootstrapping to see this one is significant or not, the first thing that here we can get is negative interaction effect. But what was our hypothesis? Effect of perception on support is stronger for high level of moderator. So should be positive and significant. But here is negative. This is first sign that we cannot support hypothesis, because our hypothesis was positive, stronger for high level. But the results show this is weaker. Effect of economic perception on support is weaker for high level of involvement. So let's run bootstrapping to see this is significant or not. This bootstrapping, you know, I just put a subsample of 500 to do faster. But for analysis, you have to change to 5,000. Okay. Now, if we go to here, is 1.73. It's t-value, right? It's t-value. So it's significant or not? Based on t-value. Anyone can answer?
Yes.
Yes or no? Yes. What? Why? What's the threshold for t-value?
Oh, 5, 3.
The threshold for t-value is 1.96.
Oh, 96, yes. 96.
But for two-tail. For two-tail. But for one tail is 1.64. So your answer is correct. This one is significant because our moderation hypothesis was one tail. We mentioned effect of X to Y perception to support is stronger or involvement moderate positively. Effect of perception on support. So we have one tail hypothesis. For one tail hypothesis, T higher than 1.64 is significant, right? Okay, now let's look at the result in here, result here. Okay, what we want to see, we want to check this effect, moderating effect to support, this interaction effect, right? Okay, here you can see p-value is significant because this p-value is one tail p-value. One tail p-value, and t-value higher than 1.64 is significant, right? If we go to confidence interval, bias corrected. But based on confidence interval is not significant. It's very, very close to 0. 1 is very close to 0. So upper level is 0.002 and lower level is minus 0.151. So 0 falls within this range. So based on confidence interval bias corrected, we cannot support. But maybe based on this, okay, based on this one also we cannot support. But based on p-value, we can. Right? But p-value also is very close to 0.05. If we consider this p-value, so we can support moderating role of involvement. But my question here is significant p-value. Consider p-value, don't consider confidence interval. Consider p-value and t-value is significant. But based on this result, can we support our hypothesis or not? Any answer? Our hypothesis was involvement moderates positively effect of perception on support, or effect of perception on support is stronger for high level of involvement. This is our hypothesis. Result significant. So we have to support this hypothesis or not?
I think yes, we can support this hypothesis.
Yes. Any other answer?
Could it be inconclusive because the p-value and then the confidence intervals are giving two separate?
Okay, but don't consider contradictory result by p-value and confidence interval. This is another issue. I agree with you. When we have this contradictory result, we follow confidence interval because confidence interval more conservative. But don't consider this one now, and only based on p-value.
Oh, then significant. Yeah.
Significant. But I say no. Why?
Perhaps because this only significant under the bootstrap.
No, under bootstrapping is significant. So we have significant p-value. So we don't actually we cannot discuss based on this value. This value shows significant role of moderator, significant effect of interaction effect. But still, I believe that we cannot support this hypothesis. Why?
Because of the coefficient is negative.
Exactly, well done. Because our hypothesis is involvement moderates positively, or perception, effect of perception on support is stronger for high level of involvement. But here shows coefficient of interaction effect negative, right? This is negative. So negative effect means effect of perception on support is lower, is weaker for high level of moderator, for high level of involvement. So even this p-value is significant, but the direction of result, the direction of interaction effect, the sign of interaction effect is different with hypothesis. So even the result is significant, p-value is lower than 0.05, but we cannot support hypothesis. Okay? But if our hypothesis, if in hypothesis we don't refer to sign and only we say involvement moderate relationship between X and Y, so this can be significant moderator, right? So to interpret moderator, we have to consider two different criteria. One, interaction effect, coefficient of interaction effect. Coefficient of interaction effect should be significant. One. Second one, we have to check sign of interaction effect. If in moderation hypothesis, we don't have sign, so our hypothesis is two-tailed. So can be negative or positive, can be stronger or weaker. So any sign, any significant coefficient we get with any sign, we can support hypothesis. But if in hypothesis we have sign, we have direction, and our hypothesis is one tail, we should interpret based on sign of this coefficient. based on sine of beta coefficient of interaction, right? So to interpret and to assess moderating variable using interaction effect, we have to create interaction effect, and we have to assess significance of interaction effect and also sign of interaction effect, and interpret based on sign and size, sign and significance, right? Is it clear? Okay. So this is the way actually that we use software for assessment of moderator using interaction effect approach, interaction effect method. We need to create this interaction term and then assess significance of effect of this interaction term on DV. We don't interpret and we don't look at effect of involvement to support, because this is not important. This is not meaningful. Even this is not meaningful. So we don't interpret this one, right? We don't interpret this one. Only we interpret this interaction effect. Sign and size, significance and sign, right? Okay. Any question for interaction effect? Any variable, any moderating variable, you actually, for any type of moderator, when you apply interaction effect, you need to follow same steps. Here, moderator is involvement. If moderator is gender, right? So you need to do exactly same steps. Okay, let me delete it and delete this one. Okay, age, gender. So this is gender. So for gender, you have only one indicator. When you create gender, you have only one indicator. So this is gender, and you connect this again, same step. Moderating, click. Here moderator is gender. Independent variable is perception. So you have this indicator, you have this interaction effect. Now this interaction effect is gender, interact, perception. Okay, when you run analysis, you can get result for interaction. This is result for interaction. Now you have to interpret. You have to interpret based on this result. When you run bootstrapping, you can see the result is significant, is not significant. And what about hypothesis? If you hypothesize one tail, for example, 1 is male, 2 is female. In your data set also 1 is male, 2 is female. So high level is female and the low level is male, right? So you can interpret positive or negative effect and based on literature and based on your hypothesis development. Okay. Any question? No. Okay. Actually, this is the way that we, by using interaction effect, by applying the interaction effect approach, we can assess moderator. We have another type of method for assessment of moderator. If we go to first, on the first slide, okay, interaction effect is one method. Another method is multi-group analysis. And multi-group analysis is for some situation that we want to assess differences between path coefficient, for example, for all paths, right? Or for categorical variable. For multi-group analysis, actually, the steps are a bit different with interaction. In multi-group analysis, we have to split our data to two groups. For example, if we have two groups, right? Or for three groups, if we have more than two groups, 3-4 groups, right? So we have to split our data and then run analysis based on each data set, based on data for each group. And then we can compare path coefficient. We can compare path coefficient between, now let's say between two groups. So, for example, we have gender, and we want to apply multi-group analysis instead of interaction effect. So, using multi-group analysis, we have to split our data to male and female. So we have two different data sets, and run model using group 1 male and group 2 female, and compare path coefficient between group 1 and group 2. So using multi-group analysis, actually we calculate path coefficient, we calculate beta coefficients separately. And then we check difference between B2 coefficient from group 2 and coefficient from group 1. If difference between path coefficient between group 1 and group 2 is significant, so it means there is significant difference for between path coefficient of group 1 and group 2. So moderator gender, for example, gender here is significant moderate. So you can see the steps for multi-group analysis is totally different with interaction. In interaction effect, we don't split our data. We don't divide data to two groups. Only we create interaction term. But in multi-group analysis, we have to divide our data to two different groups, two different data sets, and run model and calculate path coefficient based on data from group 1 and data from group 2, and then see the difference between group 1 and group 2 and check significance of this difference. The concept is exactly same. But the method for analysis, the method for assessment is different. Okay. This one especially is very good when you want to compare all relationships. If you want to see moderating effect of gender, for example, for all relationship, using interaction effect, you have to create many different interaction effects, because each interaction effect involves one IV and moderator. So for another IV and moderator, you have to create another interaction effect, right? Am I right? For example, here, if I want to assess the moderating role of involvement, not only for this one, for this one, for these three, and these three. So I have to create seven interaction effects, right? Because each interaction effect only involves one IV and moderator. So for this one, this IV and moderator. For these three, this IV and moderator, this one and moderator, this one and moderator. And for these three, this one and moderator, interaction between this variable and moderator, and this variable and moderator. So we have to create 7 interaction effects. So creating 7 interaction effects will influence all the relationship in our model. So this is not suitable for, actually we cannot get proper result. If we have this type of moderator that moderate all relationship, is better to apply multi-group analysis instead of interaction effect. Right? Okay.
Yes.
For multi-group analysis, actually we have different methods. We have parametric test for comparison between, or calculate the difference between pad coefficient in first group and second group. One is parametric test. Another one is permutation test. And we have also a non-parametric test suggested by Hensler. You can see my screen, right? 3 approaches of MGA. Right? Okay. So, but parametric test actually is not the suitable test, because this B1 minus B2 is a non-parametric term. So parametric test is not suitable. It's better to apply non-parametric test. These two, permutation test and non-parametric tests developed by Hensler, these two are actually non-parametric method to compare pad coefficients between two groups. So it's better to apply these two tests. But before comparing pad coefficient, we have to check using MGA. We have to check invariance, measurement invariance. What measurement invariance means? Measurement invariance means our measurement model for two groups for group 1 and group 2 should be invariant, should not be different measurement model. So loading, weight, and other criteria for first group and second group should not be significantly different. Why? Because we want to assess, we want to compare path coefficient. If we don't check measurement invariance, maybe the difference between paths come from difference between measurement models, not between path coefficient. So before running MGA, multi-group analysis, and comparing path, we need to make sure about measurement invariance. So for MGA, measurement invariance testing is a requirement. Is a requirement. So without measurement invariance, we cannot go to MGA. We cannot perform MGA. There are different methods for measurement invariance. Parametric method is one method, and also we have some non-parametric method. But using parametric method, when we check loading, because loading, weight for formative are main criteria for measurement model. At least 50% of loading or 50% of weight should be similar and should be insignificant difference between 50% of loading or weight between two groups. So we have to check difference between weight or difference between loading for two groups, and at least 50% should not be significantly different. If 100% all loading and weights are not significantly different or same, so we can get full measurement invariance. But if it's 50%, we can get partial measurement invariance. But the testing difference between loading and weight actually is a parametric approach for invariance testing, for measurement invariance testing. Recent literature suggested another method, especially for PLS. This method called MECOM. MECOM stands for a measurement invariance for composite model. Measurement invariance for composite model. This MECOM includes 3 steps. In first step, for measurement invariance, we have to check configural invariance. And in configural invariance, we have to make sure about same algorithm, same missing value imputation, same item for each construct in 2 groups. So we need to make sure about same algorithm, to apply same algorithm for 2 groups. This is configural invariance. Second step is compositional invariance. In compositional invariance, we calculate correlation of each construct between group 1 and group 2. And this correlation should be 1. Should be 1. So if we pass these 2 steps, configural invariance and compositional invariance, so we can get partial measurement invariance, and we are able to run MGA. But there is another step in MECOM, measurement invariance for composite, is equality of mean and variance of construct in two groups. But this is not requirement for MGA. Only if you want to merge your data. For example, you collected data from two different countries, right? So you do a cross-country study. Collect data from Malaysia and China, US and China. So you compare these two data. To compare these two data, to compare model for each one for these two data set, only we need partial measurement invariance. But if you want to combine data from China and US and run model based on merged data, so we say pool data, we can pool data from different sources. So you want to run model with pooled data, you have to get full measurement invariance. And we need to pass also step 3. So we need to confirm mean value of construct between two groups and variance of construct between two groups are similar, are identical, are not significantly different. But it's not necessary for multi-group analysis. It's not necessary for moderating assessment. For moderating assessment, only we need to check configural invariance. So apply same algorithm, same item, and compositional invariance. Correlation between constructs should be 1. Should not be significantly different from 1. Okay. So if we decide to apply multi-group analysis to compare coefficient between groups, we have to check measurement invariance before MGA. Measurement invariance, we have parametric test. So for parametric test, we can check, we can compare loading and weight between two groups. And at least 50% should be insignificant. So with partial measurement invariance, we can go for MG. Or we need to apply MECOM. And in MECOM, we have to pass step 1 and step 2 for partial measurement invariance. But step 3 is for pooling data, is not for MGA, right? Okay, let's go to software and show you how, any question? So let's go to software and see how we can run MGA. For example, for this model, we want to test difference between all relationship, direct and indirect relationship between male and female. Between male and female. So here we have one relationship, 1, 2, 3 here, and 3 here. So we have 7 relationship here, 7 effects here. And also we have 3 indirect effects, right? 3 indirect. So we have 10 effects. If you want to introduce, if you want to use interaction effect, almost is not possible. Right? So it's better to apply multi-group analysis. But for application of multi-group analysis for assessment of moderation role of gender for all relationship, all effect, not only for one. Your assignment is only one effect. So for your assignment, interaction effect is applicable. But if I want to check moderating role of gender for all relationship, I have to run MGA. Okay. So to run MGA, first step is to split data to two groups, male and female. How we can do it? In a SmartPLS software, if you click on your data set, okay, if you click on our data set, here we have some option to generate group, to generate data group. Okay, if we click on generate data group, click generate data group, so you will transfer to this page. We change this one to gender, for example. Name of the data groups is gender. But what's the grouping variable? Grouping variable is gender, because in gender, under gender, we have two groups. So we want to group our data based on gender. So in first column, when you click, you can see different variable here that you can do grouping based on these different variable if you have a categorical variable. If you have a categorical variable, okay? But I want to group based on gender. In gender, I have two values. So this grouping will be done based on these two values. So if we choose gender, we will have two groups, right? So we click on gender. Minimum cases per group. You can keep default this one, or you can change any values that you want. Sometimes you have the minimum sample size for each group, and you want to group based on minimum value, right? So you can change this number. For example, if I change to 100, so it means you do grouping, you create group data if at least there is 100 sample under each group. Okay. Okay. Clear. We have two groups, and under each group we have more than 100 samples. One, the value of one is male, right? And two is female. Higher value of gender we know based on our data set and SPSS file, we know two is female and one is male. Here we can change the name, okay, to make it easier to use. Here, if we click on edit, we can change the name. So the value of one we can change to male. And two we change to so now we have these two groups. Male includes 165 samples, female, and male 247 samples. For multi-group analysis, we don't need to have same sample for each group. Can be different. Here you can see number of cases under male and female are different now here. But under each group, you need to have minimum sample size. You need to have minimum sample size for your analysis. Okay. So now we created these two groups. You can close your data. So under this data set now you have two groups. Okay. Before going to multi-group analysis, just want to show you, if we perform PLS algorithm, if we perform original analysis of PLS. So if you click on PLS algorithm, here you can choose this group that you have under data groups. Under data groups, you can choose these two groups. If we select all, so we have these two groups, and we can start calculation. If we choose these two groups, what happens? If we choose these two groups, we will have data we will have three sets of results. Result for complete data, result for female, and result for male. So when we generate group, actually in original analysis, in regular analysis for assessment of measurement model and structural model, also we can get results separately for these two groups. Okay, here also you can change in this part. Okay, here you can see the result in this window, but if you change data group, for example, to complete, okay, you can see this change. If you change to female, for example, effect of perception on support for female is 0.366 and for male is 0.209. So you can see significant difference between effect of perception on support for male and female, right? So, but it's not part of MGA. It's only to perform analysis. I wanted to show you that when you generate the group, you can run analysis for complete data and for each data group, right? And you can have the result for measurement model and structural model. For example, for measurement model, if you want to check reliability and validity, right? This is the value for male. But if we change to female, you see the value will be changed. So you can get different results for assessment of measurement model and a structural model for each group. Okay, but this is not part of MGA. This is not part of multi-group analysis. Multi-group analysis, when you click on calculate, is here. But before multi-group analysis, we have to check measurement invariance. Measurement invariance is not part of multi-group analysis. You have to run permutation. So before MGA, you have to run permutation. So click on permutation. And for permutation, you want to compare two groups for measurement model. So two groups are male, female, and male. And you can choose number of permutation. Again, calculate permutation. Okay. Here you can choose the permutation number. Literature suggests 5,000 for permutation, but I changed to 500 to get faster result. If I choose 5,000, it may take a bit more. So just keep 100. This can be one tail or two tail, but for MECOM and measurement invariance, you can keep two tail, because for measurement invariance, we don't check which one is higher and lower. Only we need to check significance or insignificant difference between measurement. So start calculation. So when we get result of permutation, okay, here we have result of permutation, but only we need MECOM result. MECOM result. So when you click on MECOM, but MECOM, we have only a step 2 and a step 3. We don't have step 1, because actually step 1 is not something for calculation. A step 1 is to make sure that algorithm, missing value imputation method, item for construct for variable in two groups are identical or same. So it's not something for calculation. Only we need to make sure identical item and all algorithm for two groups. So if we step 1 can be passed only by checking the situation for two groups, algorithm for two groups. Step 2 is compositional invariance. This is correlation. This is correlation for community attachment, correlation of community attachment between male and female, between group 1 and group 2. So the correlation is 0.997. Second one is correlation between economic gain in group 1 and group 2. Perception, group 1 and group 2. Environmental attitude, group 1 and group 2, and support. So this is the correlation. This correlation, the value of this correlation should be, here we have confidence interval, but only we have lower level. So this value should be between lower level of confidence interval and 1. So this value should be in this range, between lower level of confidence interval and 1. Here, correlation is 0.997. So it's between 0.975 and 1. So it means this correlation is not significantly different from 1. So this correlation also is 1. This correlation is 1, correlation is 1, correlation is 1. So the correlation should fall within this range. Lower level of confidence interval and 1. When fall in this range, it means this correlation is almost 1, is not significantly different from 1. So if we have this correlation for all construct, so we can pass compositional invariance. When we pass configural and compositional invariance, we can go for MGA. But let's check step 3. Step 3 is not requirement for MGA, but we can check step 3. In step 3, you can see some mean difference and variance variance is not significantly different, but the mean of perception is significantly different in these two groups, right? So this is mean value of economic perception minus for male, female minus male. So it's negative. Negative means the mean value of female for perception is significantly lower than male. It's the meaning of negative. It's female minus male. And it's red. Red means negative. Red means significant. We need to look at this permutation, these two values, low and high level of confidence interval. But this confidence interval is created based on permutation. So when this value is significantly different from 0, or between two groups are significantly different, when doesn't fall between these two values, doesn't fall. Okay, here the difference is minus 0.215. Lower level is minus 0.20, higher level is 0.191. So this is out of range. This is out of this range. So this one is significantly different from 0. Or in other words, mean value of perception significantly different between female and male. So when we have at least one insignificant difference, at least one, so it means we cannot pool, we cannot combine data. We cannot combine data. But for multi-group analysis, only we need step 1 and step 2. Okay, when we make sure about partial measurement invariance, we can run now MGA. And for MGA, okay, one group is female and another group is male. And start calculation. Okay. Here you can see result of PLS MGA, parametric test, and some other tests. The best one is PLS MGA, is a non-parametric approach. Right. This is difference between pad coefficient. This is difference between pad coefficient. And this is p-value. You can see all p-value are red and higher than 0.05. So gender is not significant moderator for any of relationship and effect. So here we can test moderating role of gender for all effect. And this result show gender is not significant moderator for all effect. So using MGA in one run, in one analysis, we can get result for all relationship. But in interaction effect, we have to run one by one. Right? But for MGA, for performing MGA, we need to make sure about measurement invariance. At least we need partial measurement. Okay, that's all.